If you're planning a pilot involving generative AI, you've got a lot of options on the menu. Of course, there's OpenAI, including GPT-4 and 4 Turbo and 3.5 Turbo and DALL-E 3 for images. There's Google's Palm 2 with access via Vertex AI or other ways, and Google's Gemini family of models, which have a multimodal focus. There's Meta with its Llama 2 models. There's Anthropic, which just announced its new Claude 3 family, including Haiku, Sonnet, and Opus. There's Cohere, which has now announced Command R for retrieval augmented generation. There are numerous open source options on HuggingFace, including Gemma. There's Eleuthère.ai. To give an idea of the scale of total options, here's a scatter plot on GitHub showing a partial list of LLMs that are specifically just for English to Japanese translation. The source table for this shows 284 options in all, just for that one task alone. The problem is, it's been proven that we humans actually don't like having so many choices. You'd think we'd love having lots of choices, but instead, we become uncertain and confused. That effect is referred to by psychologists as the choice paradox, and it leads to what the rest of us refer to as analysis paralysis. Our fellow human beings much prefer to have only 2 or 3 choices, especially if someone can point and tell us which one of those is the best. Which leads us to the topic of no free lunch. Use of that familiar phrase in a machine learning context is attributed to computer scientist and statistician David Wolpert, who used the phrase in this paper. It's a colorful way of describing a pretty obvious point, that there's no one-size-fits-all model that performs best across all problem sets, that there are trade-offs. And that basic principle certainly applies to large language models. The fact is, different LLMs are good at different things. They're intentionally made that way. Therefore, we'll usually want to compare different models during the pilot phase of our project to see how it turns out. And doing that makes sense. Firstly, because the very act of comparing can give us a better sense of what's possible. And this evaluation process quickly leads to useful metrics, because we'll need to compare and rank our options on different types of KPIs. And that also helps with benchmarking and with setting objective standards for the live implementation later on. And all of this helps to get a better understanding of trade-offs between different kinds of desirable features. But how do we do all that, actually? For example, if I want to do A/B testing for a marketing campaign, there are well-known tools for that, like Optimizely, Unbounce, and Crazy Egg. Or there's functionality on Salesforce Marketing Cloud, or third-party apps on their App Exchange. Or if we need to do hyperparameter tuning for a machine learning model, there are frameworks for that as well, like the ones shown here. And it turns out that there are also platforms for tuning and comparative testing of LLMs. One nice option is Vellum.ai, which you can see here. It's a low-code developer platform that's designed for building and deploying large language models. It's got easy-to-learn tools for prompt engineering and for performance monitoring, and for version control, and it has tools for measuring and tracking side-by-side performance of different competing LLM models, which is really useful. Also, there's Gradio, which is an open source platform that's designed for building interactive language model demos. Gradio doesn't have all the same production features as Vellum, but it's a great option for a quick proof of concept. Here's a good demo by Patrick at Assembly.ai showing how to get started with that. It's well done, so I'll leave a link to that for you in the comments in case you'd like to check it out. There's also HuggingFace, which is not only a repository for open source LLM models and code, but also for toolkits. More than 7,000 in all, which includes tools for deploying models or building APIs. There's also Lambda Labs, which is a commercial platform that specifically caters to enterprise-grade LLMs. The Lambda website describes features that are similar to Vellum, like prompt engineering and performance monitoring, but it looks like it might be more expensive. Paperspace is another option, although it might have a steeper learning curve than the first two I talked about. Here's a summary of the different platforms I mentioned just now. So, after we pick a platform, what is it we're actually comparing? Well, there are various metrics, including response accuracy, of course, plus recall, which is the desire for the model not to say, "I don't know," when the answer should actually be available. There's model resilience to unexpected prompts, for example. And there's something called semantic text similarity. And besides performance measures like those, we also need to compare on operational measures like latency, for example. And finally, all of that gets evaluated as a whole against cost. Here's a good article by Vellum founder Akash Sharma walking through the mechanics of how you'd actually go about testing multiple options on these kinds of platforms against some of those metrics that I mentioned just now. There's good detail in there with examples, as you can see here. So I'll leave a link for you in the comments for that as well, in case you'd like to read that. And so, as Wolpert's axiom indicates, there's no one-size-fits-all best large language model, but at least there are platforms designed to help to do comparisons in an efficient way, while also building out the models themselves and deploying the final model for production. And that's a pretty good tip that sometimes gets overlooked in some of the recent project planning documents that I've seen. So I hope that helps you out. Meanwhile, thanks for watching and see you next time.